Hello, everybody. I hope you're all doing well and you're ready for more of our Alberta math contest, high school math contest. We're looking at question 15 now. Triangle ABC has area 1. X and Y are points on the side AB. Z is a point on AC. I'm going to start drawing this. So A, B, C, X, and Y are somewhere on here, and Z was on AC. We'll adjust this as we learn more information. XY is twice AX. Actually, that kind of looks close. I'll move the dot ever so slightly closer. So whatever this length is, I don't know, call it K. This is 2K. XZ is parallel to YC. Oh, this is fantastic. My first drawing is almost... we'll move Z up a little bit. My first drawing is almost never exactly what it looks like. Oh, we're not done reading it. I may have screwed something up. YZ is parallel to BC. That one needs a little more work. So I guess lower B a bit. Oh, I'm starting to see things that might be... I feel like we're going to have some similar triangles. Parallel to BC, the area of XYZ is. So we want the area of this triangle in here. Ooh, okay. So we've got some parallel lines. I'm going to highlight them in colors to visually signify to me which things are parallel to which. We don't have any other length information, do we? We do know the triangle has area 1, so I have a feeling we're going to use these ratio between this k and this 2k as 1/2. I'm going to predict the answer is a quarter or something like that. Now, it looks like everything's in terms of thirds, so I might not be so lucky. Okay. Anyway, so parallel lines always hit a common line at the same angle. So we've got the same angle here, which I guess we'll put in color, maybe yellow, as down here. And same thing with these blue ones. They always hit at the same angle here. Okay. Now, I'm willing to suspect that the green ones and the yellow ones are actually the same, but I don't have the wherewithal to prove that right now. But it would certainly make this question more interesting. What can we say? What else can we do here? Well, if I introduce an angle here, we'll call it the purple angle. We know purple and green add up to this angle. But the red angles need to hit AB at the same. And since we've already got green here, that means this will be purple as well. And the blue parallel lines hit AC at the same angle. So, and that's clearly purple, yellow. So we've already got a yellow down here, so we'll have a purple here. Okay. So we definitely have some nice angles going on here. Or maybe it's that... No, I was about to say maybe green, yellow, and purple add up to 180 because those are the angles I'm seeing. But of course we've got... no, we never used... I was about to use the green, but we've already got a green. let's use cyan up here. So I can see that cyan, green, purple, and yellow must add up to 180 thanks to AXZ. Okay? So that means that we have green plus cyan here. And inside XYZ, we will have yellow plus cyan. We'll also have a yellow plus cyan down here because of this 180. Or because they hit at the same angle. Okay. So, what can we do? So we know, let's start getting some of the sides involved. And actually, I think I want a bigger picture. Because I'm not doing a lot of writing, I'm doing just sort of a lot of coloring. What were those relationships? Yeah, that's close enough. And then that one needs to go up there, and that one needs to go there. And then... No, I have too many here. Oops. It's just one zigzag. There we go. K, 2K. Red parallel lines. Blue parallel lines. We had cyan up at the top. Yellow cyan, something cyan. I think it was green. Green here, green here. Yellow, 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 yellow. Called this purple, purple. And I think this one down here is purple as well. Yep. And we'll just add in the little plus signs for completeness. Okay. Oh, I need green and purple here. All right, there we go. So now this triangle here is similar to this bigger triangle here, which means their sides have a common ratio. So this side, the side that has the cyan blue, is K, and it corresponds to this bigger side that has cyan. I said cyan blue. Cyan and then green purple. And then cyan, green, purple down here. So it's the same side, but now it's 3K. So the sides have all blown up by a ratio of 3. So to call that K, maybe call this one length L. Then this would have to be 2L to make the whole thing 3L. And if this here is M, then this one needs to be 3M. Okay, so let's get rid of the green. I've got K, 2K, that was given, so we made L and 2L. We have M and 3M down there. Okay, but now we've got, we'll use the forest green again, another similar triangle, because we've got the cyan and the yellow-purple. Well, we've got yellow-purple down here. So 1 to a side of 3. So if we call this here N, this one down here must be 3N. And this side here is 3k, so the whole thing must be 9k. Okay, but then that puts this at 6k. Okay. And now you can notice that, oops, this triangle in here, the one that we care about, the X, Y, Z triangle, is congruent to this one here. So let's give names to these areas. Let's say P, Q, R, S for our areas. Okay. Now, because this triangle with area P was similar to the big triangle with PQR as its area, with a common ratio of 3 on the sides, then the big triangle has an area 9 times. So when you've got triangles that are similar, you've never seen this before, and they've got you just scale up all the sides by a certain amount, the area scales up by that common ratio squared. So common ratio is 3, so the areas scale up by 9. Okay, so there we go. That's a nice little relationship. Then we had this triangle scaled up to the big triangle, so P plus Q. And then that triangle scaled up by 3 on the sides, so the area will scale up by 9. And that's P plus Q plus R plus S. That's the full triangle that one's scaled to. Okay. And then we know that triangle S is scaled up by 3 times version of triangle Q. So the areas are like that. And we just need to solve for Q. So let's put these equations together. Okay. P plus Q plus R plus S is 9P plus 9Q. Okay. We also know that the area of the whole thing, which is P plus Q plus R plus S, is 1. Now, if I take this first equation and subtract it away from the second equation, we'll see that S is 9Q. But what else did we learn? Oh, no, we already knew S was 9Q. Okay, never mind. Let's see, what can we do here? Well, we can rearrange and say R is 9P minus, or 8P minus Q. Right, and then, so then 1 is P plus Q plus 8P minus Q. Plus S, which is 9Q. Oh, okay. I'm not seeing a way to eliminate and just get Q on its own. There's something we're missing with R. Or is there another triangle that I'm missing altogether? So Q plus R is 8P. No, I know that. And we want the area of Q. I can see 1/9 is P plus Q, but we just want Q. So R plus S would be 8/9. But I've got two equations and 4 unknowns. I shouldn't be able to get Q by itself. So that's why we need another equation. S is 9Q. Or is there something with these answers that makes it impossible? Like P plus Q needs to be 1/9, so Q could not possibly be 1/9. It could not be 2/9, could not be 1/3, could be 1/7, or it could be 2/7. Both of those are less than 1/9. But which one is it? That's the problem currently. I don't have a relationship between P and Q, so perhaps we should focus on that. All right. Have I missed any information? XY is 2 times AX. That one's fine. We know the area is 1. Z is on AC. Parallel, parallel. Ah, there it is. That's what it is. Okay. So if we look at that smaller triangle up there, they both have a point. They both have the point Z in common. So we've got Q, we've got P, but their bases are different. So if we rotate the whole thing, base of K, base of 2K, but they'll have the same height H. So Q has twice the area of triangle P. So Q is 2P, and so now 1/9 is 3P. P is 1/27th. Doubling that, Q is 2/27. There we go. B. Okay. While I was the reason I was thinking about that is, we know that they add up to 1/9. One of them would so Q has to be one of these two answers because we don't have a none of these option. Okay. And so, okay, one of them would be 1/27th, the other one would have to be double, and that's when it clicked that, oh, these are triangles with bases on the same line and the same sort of apex point set. So that's what I was missing, that relationship there. I was too hung up on the similar triangles. There we go, we get B, and I can rest easy as we move into question number 16.